Good day everyone, I'm Luke and we're going to be talking about some series and parallel AC circuits. Hope you enjoy. First of all, it's very useful to remember that a lot of the laws and concepts used to analyze DC circuits can also be used to analyze AC circuits. Be careful though, make sure that all your values are consistent, such as peak, peak to peak, or root mean square. Such concepts that can be transferred include Ohm's law, Kirchhoff's current and voltage law, voltage and current divider rules, Thevenin and Norton equivalence, and nodal analysis. Although so far both currents sound very similar, there are some very important differences which are responsible for the different ways that both these circuits can be utilized. DC is voltage and current of a constant magnitude, whereas AC, as the name implies, alternates between positive and negative values with respect to time. With a standard AC sine wave, the average value for voltage would be 0, however there's still obviously power being transmitted. To help explain this, the complex number plane is introduced, and with it the concepts of reactance and impedance. Due to time constraints, I'm just going to try and focus on what this means for circuit analysis. Reactance, measured in ohms, is a complex vector quantity that can be obtained through these following equations for capacitance and inductance. Note that the frequency is dependent for these equations. Resistors, capacitors and inductors can all be represented as individual impedances. Like resistors, the sum of the total impedance in a series network can be given by the sum of the individual elements. And likewise in parallel, the inverse of the total impedance, or admittance, can be given by the reciprocal sum of each element. When calculating impedances, it's important to remember that it's a vector. For inductors, it's positive 90 degrees, and capacitors, negative 90 degrees. These characteristics have their effect on the circuit by shifting the phase of the voltage and current waveforms. To help remember this, you can use the acronym CIVL to show that in capacitive circuits, current leads voltage, and in inductive circuits, voltage leads current. Something to keep in mind when working with these complex vectors is that polar form is needed for multiplication and division, and rectangular form is needed for addition and subtraction. For example, using the voltage divider rule with impedance instead of resistance, the denominator will have to be calculated in rectangular form first before being converted to polar for the rest of them. When working with complex circuits, always try and reduce each kind of componentry down to a single component to ease analysis. I hope you learned something and enjoyed the video. See you next time.